Yes, Aniruddhaji.
Sir, in the area that you had shown, all the multiplexers or the decoders were written by hand. Don't we have like standard modules we can use or anything like that? Like, you know, like a standard decoder.
Yeah, so Verilog doesn't provide. What do I mean by Verilog? So for example, when you write a C code, in C code, there are some intrinsic functions which you can always use. For example, printf and all these for and this construct. But whenever you are doing any functions, for example, if you want to do log n or you want to do sine, you want to do cosine, then you have to include math library. Correct. So
Yes.
those libraries are there, and those libraries would be provided by somebody. Okay, I have not first of all included any library, and unfortunately in Verilog we don't see any standard libraries also.
Okay.
Then we are using, so for example, if I'm compiling using, there's a very good reason that these libraries are not there, because all these modules are also not very standard. You need to tell, you need to clearly tell that what is the position, what is the name of all these parameters. Correct. So
Yes.
somebody has to share the code, or they have to give the library in such a way that only the definitions are there. For example, the header files in C++. Okay. So that's why what sometimes people do is, for example, Synopsys has shared their designware library. So if we are using Synopsys synthesis tool, then we can use their designware library. In their designware library, there are multiple of those components which are there. Similarly, if we are using Xilinx also provide multiple of these IPs. We can use them as a basic design. Otherwise, yes, it's a one-time effort. We write it. I have written it myself because it. Again, I could have created a module and then reuse it, but because it was a small part, so I wrote it myself.
Okay, so for each like application or each digital design project, they create these decoder and mux modules that they will use through the entire project, if it is a large project in that case.
So if they have created, say it again.
No, if I'm designing a very large project which has like maybe like hundreds of muxes, then I will design one mux in one module and use that everywhere, right?
Perfect. Yes.
Okay, that's all.
Yeah. Okay. This also solves your problem that sometimes your mux is you don't know how many input mux you require. Correct. So if you know your design, then either you can write the parameterized mux the way I have written. Otherwise, you can also otherwise you know that which bit you require. So based on that, you create those muxes.
Okay. Yeah.
Yeah. I have a couple of questions. When do we get error unable to assign L value in Verilog? So this is a very standard error. So L value means left value, R value means right value. So whenever your left value is incompatible with your right value, as I when I was discussing my code and I did this duplication, basically replication. So this replication was done because I wanted to match the bit width of left and right operator. Okay, so otherwise sometime during compilation it will not give error, but when you will simulate, when you will elaborate, then it may give error, or when you will run, then it can give error. So because of it's user's responsibility, designer's responsibility, that he matches L values and right values, both in terms of width as well as in terms of type. So types are also varying. So here we are using only bit types, but there are other types which are possible, like can have integers, real, etc. Yeah, so like yesterday, I'll share the link of the code. So what I'll do today is I'll put that in my this slides, and you can use it. In case we write a behavioral in case we write a behavioral modeling in our code, we use loops such as for, while, how they are implemented. In hardware, correct? Just a minute, I lost that comment. So one thing which is sure, if we are using data flow and structural model, it will always be synthesizable, but some constructs of our behavior model, they are not synthesizable. Okay, and how these for and while loops would be synthesized. So I think it is module 4. Professor Sahula ji will tell you more clearly. So he will tell you by doing scheduling, register allocation, binding, that how those for loops are actually disambiguated and then created into a node of networks and then finally synthesized into operations. It is completely safe. The only thing is the behavior model, you will not be sure how many cycles it will take or how much time it will take. Okay, so we also use behavior model. The way we will try to use behavior model is we'll say that we'll do it tomorrow. So whenever we are writing sequential code, sequential design, in case of sequential design, there would be cycles involved. There your design would be done in multiple cycles. So each cycle you would be able to say that at the rate of clock. So that means in each clock, whatever need to be done, you will try to keep that. So there we will use behavior because there is no, first of all, there is no alternative, and there it will also make sure that things whatever is done in that always loop would be synthesized. So there are multiple options for these for and while loops. So sometime your Verilog compiler will try to unroll them or will make them as an individual loop. So this for loop is essentially different than this where. So whatever for loop we used for this creating the adder, which is a very specific for loop, which is called genvar. So if we are using genvar variable, so that means it will be always unrolled. But in case of a behavior, we are not sure whether it would get unrolled or whether it would be synthesized into multiple cycle circuit. In the ALU example, so the next question is from Harsha. The question is, in ALU example, the operation depends on opcode, which is 3-bit. So could you use statement to set the arithmetic operation? For example, opcode test assign. This is difficult. Wait a moment, I will go to that comment and we'll see that. Yeah. So the question is, in ALU example, the operation depends on opcode, correct, which is 3-bit in this case. So can we use case statement? So if you want to use case statement, then you have to use behavior. So I have restricted myself that if I'm writing combinational code, I will always use data flow or structural. I don't impose it onto you, but this is the design which I follow. The question is, in real-time ALU design, do we have clock signal? In real use cases, ALU is always a combination block. If at all clock is there, the clock is there just to register the input and register the output. In between, there will not be a clock signal. So yes, the clock signal can be there if you are using multiple cycle operations. For example, your multiplication is done in more than one cycle, then you need to use clock inside also. Otherwise, clock is there only on the boundary. The next question is, can I instantiate module define in another V file into my required file? Yes, we can do that. Or should all the modules be in the same V file? So, if your project is large, if it has like thousands of lines, then it is always good to break your code into multiple of these files. And I don't know how we can do it in EDA Playground, but yes, if you are using any of the other Verilog compiler, like if you are using, for example, Xilinx Vivedo or model sim, then you can include all the files in your project, and then it will automatically try to figure out that what are the dependencies, which files are required to simulate your top file. Can you explain wire data type in Verilog, when to use? So wire is like a standard wire in our hardware. So that means whenever we need to connect to two components, then we need to use wire. So it is also created to have a different variable names. And again, wire would be used whenever you're using data flow. So, but whenever you're using data flow, whenever you are using behavior model and you are writing to a particular variable inside this always loop, then you have to use reg. You cannot use while. The question is, what do you mean by elaboration? Okay, elaboration is a one specific phase of HDL, VHDL or Verilog simulation. So for example, in C, there are only two phases: you compile and then you run. Here you have three phases. One, you compile, and when you start running, there are two phases. One is elaborate, and then you start the simulation. So in elaborate phase, all the linking happens. You will see which components would be connected to each other. You will also initialize all the components. Initialize means if there is any initial block in any particular component, that initial block would be called. And then your simulation would be at time equal to 0 when you will start simulating. So whatever need to happen before time equal to 0 would be there in the elaboration phase. In Verilog, it is much more interesting because in elaboration phase, it will try to use the particular configuration which you have specified. So in VHDL, you have multiple implementations of the same design, so you can choose which particular implementation at the elaboration phase. So otherwise, in Verilog, in System C, in all other hardware description language, in Verilog phase, usually you do the connections. Sir, the question is, by writing depth level coding in logic terms, as in data flow modeling type, by that we can have a clear insight of designing our ALU with customized delay. Am I right? Yes. Yes, you will have a clear insight, correct. So the next question is, for any combination circuit design in Verilog, how can we conclude, how we can come to conclusion that it is optimized code and we have different modeling types? We don't know. So the only way to ensure that we have written optimized code is we should have a view of hardware. So we should not treat Verilog as a C language, means that we are dumping the functionality in terms of for loops and construct. But if we have a view that what final hardware we would like to synthesize and what final hardware should look like, then we can have a comparison that whether the final hardware is actually looking like that. So you can look, for example, in Xilinx, you can see the view of the final generated hardware. So if that is same as your expectation, then you can be assured that it is optimized. So the next question is, in full adder example, you designed cout function as a.b plus a.scene plus b.scene. It could also be done using this a plus a.b plus a XOR b cin. Any advantage, disadvantage of the approach of using which uses more gates? if you're using more gates, that means you're using more hardware, and the critical delay depends on the parallel path. So you need to find out whether which particular model requires more paths, or more critical path or less critical path. Based on that, you can choose. Another question from GPS GB is yesterday while doing full adder assignment came across this doubt: a dot B plus a dot C in plus b dot C in, but in gate level modeling we just finished with 2 cross OR and 1 OR. What is the difference between them? So actually 2 ZOR and 1 OR. See, I will give a different perspective here, that whatever we are writing, there are multiple ways to write all those things, and all of those things would be correct. But what is the objective? The objective, there could be multiple objectives. One objective is we would like to synthesize. The second is we would like to analyze the final hardware that is going to be generated. So here, our one of the objective was that we also need to understand the delays which would happen in case of a n-bit adder. So that's why we choose some delay model. These delay model may be correlated to final hardware, may not be correlated, but it gives us some insight that if these are the constant delays, then how our latency of the output would be. So there is in summary, I'm not saying there is an advantage or disadvantage. Every approach, if you are able to compile, if you are able to meet your results, you are functionally able to simulate, that means it is okay. But now the level of optimizations could be infinite. You can keep on doing optimizations, and if it is aligned with your objective, then it is well and good. The question is Yash is asking, which is commonly used model for combinational circuit, data flow, structural, or behavior. So if you will search on internet, you will find mostly behavior code. Sometimes you will find data flow also. Structural, very less people will use it. Is complicated to write and takes much more lines of code. It is mostly like a personal preference. If you would have been my student, you would be forced to do data flow for combinational logic. So this question is about genware. So genware is essentially like if you know C, C++, it is more like a macro which has to be defined at compile time. Okay, so any macro which is defined at which has to be resolved at compile time or at elaboration time here. So in elaboration time, you have to resolve this genware. So if whatever is the genware value, it will get expanded. Like a preprocessor, you will assign those values. If you are using a for loop using a genware, then that for loop will get unrolled. So let's say yesterday we have used genware as a full adder. So there would be 8 instances of that full adder that would have been created. So it is actually a completely structural model of full adder, n-bit adder, which we have created using genware. There is another question from Aniruddha. While modeling the delay of chip select module, I had to use NOT gate with AND gates, A and not B. But I don't know what is the delay this introduces. Okay, so this again depends on what is your implementation. So usually an inverter consume much less delay than an AND gate. And some of these gates, for example, A not B. So this A and not B. So this could be a primitive gate in many of these libraries. So you can use so whenever this cell binding would happen, so they would be automatically bounded to the cells which are available. So the answer is essentially that if it depends on the library which we are using. If we are using a library which has this kind of cells, then there is no cost. But if you are not using a library, that library doesn't have, then your inverter cost would be included, and inverter would cost yeah, probably half of your 2-bit adder or 2-bit AND gate. Yeah, so if there is no more questions, then I think we can stop here. And yeah, today there is no assignment. You can keep on doing your previous ones if you are not finished. And yeah, so what I can give is I can give a assignment for day after tomorrow, whatever we are discussing, so that if you want that, you can read that particular assignment and keep on working on that. Okay, so then I will disconnect this call and wish you a very nice, happy day. Thank you.
Thank you, sir, for today. I hope all of you we will meet tomorrow again, sharp 10 o'clock. Okay, enjoy the day. Thank you, sir.
Okay, bye bye.
Bye.